In this video, you will learn how to solve problems on GP, how to find the sum of a GP precisely.
Hello my dear friends and students. Welcome to another interesting class of mathematics. On today's lesson, on today's class, we'll be solving a problem on GP. Yes, precisely from sum of a GP. And what is sum of a GP? Sum of a GP, as I explained during the time of AP, that whenever we hear sum in mathematics, it simply means requires us to add numbers together. So today that we have sum of a GP, it simply means to add these GPs together. And what are we adding? We are adding the numbers, as we know that GP is simply set of numbers, just like AP. So what are we required to do? We are simply required to add up the numbers in this set of these GPs, to just add them up using the appropriate formula for sum of a GP. Let's go. Let's do the question first. And I read. Find the sum of this GP. Yes. Now what is the GP? The GP is 2 plus 6 plus 18 plus 54. And other terms that are not given. Yes. Finally, the last term is 1458. I take it again. The question is, find the sum of this GP. The GP is 2, the first term, the first number, plus 6, the second number, plus 18 plus 54 and other terms not given. Other terms not given. And the last one, according to the equation, is 1458 plus 1458. Yes. Write our solution. What we do again? We write out the data given to us in this question so that we can easily use them. We start with the first one, which is the first number. And the first number in GP is represented by A. So we write A is equals to 2. Okay? We continue. What next? We write out the common ratio, which is denoted in GP by R. So we write R is equals to. Did they give us any R? No, they did not give us any R. But we can obtain our R. How do we do it? We simply say 6 divided by 2. Yes, and that is our R. So we do it now. We say R is equals to this 6 divided by the first term, which is 2. It might be first time, or if you like, if you don't want to use 6 and 2, we can use 18 divided by 6. Yes. We can even use 54 divided by 18. You can try it on your own. You see that you still obtain the same answer. So we say R is equals to 6 divided by 2, which gives us what? It gives us 3. Okay? 3. What that again do we need? We need our n. So write n. N is equals to. Are we giving our n? No. We are not giving any n. That means we first of all solve and obtain our n before we can solve for the sum of this GP. We first of all obtain the n. Okay, so we do our line. How do we obtain it? We use a formula, a simple formula in GP, a simple formula for solving simple problems on GP, and the formula is this: A R n minus 1. The formula is A R raised to the power n minus 1. Yes. Now we begin to substitute this data into this formula. We start like this. The first one, which is A, we say it is 2. A is equals to 2. So we substitute 2 to this A, and it becomes 2. There's an invisible multiplication sign here. There's an invisible times here. So I make it visible now. Times R. What is our R? We say that our R is R equals to 6 over 2 equals to 3. So our R is 3. So it's 3. Okay? N, we did not know our N. So we still write it N. Put the minus 1 according to the formula. Equals to what? We want to obtain n, and n represents the number of times in this GP, which is how many numbers this GP contains. So for us to be able to obtain the number of times in this GP, we are going to use the value of the first and the value of the last time, so that we can be able to cover the whole GP. Yes. And now we have used the value of the first time, which is 2. Yes, so it will be equals to the value of the last time. We are going to use the two values, the value of the first and the value of the last time, so that you can know how many numbers that the GP contains. Yes, so we say 2 times 3 raised to the power n minus 1 is equals to the value of the last time, which is 1458. 1458. I hope you are following. Yes, we use the value of the first time and the value of the last time, so that you can know how many numbers that this GP actually contains, because some of the terms are not given to us. When we have known how many numbers the GP contains, it will be easy for us to sum up the numbers in the GP. Yes, first of all, know how many numbers, so that we know how many numbers we are adding using the formula. So we go. Continue. Now what do we do? We can cancel out if you like. We can cancel out, so that we reduce these numbers to smaller numbers. And how do we cancel out? You say 2 cancel itself 1. Cancel this number, you get 7 2 9. Yes, so now we have 3 n minus 1 is equals to 7 to 9. Is that clear? What do you do next? We express this number also in base 3, because this one is really in base 3. 3 raised to the power n minus 1 is equals to 729. So we express this number also in base 3, so that two of them will be in the same base. Before we now continue. So how do we do that? We simply use 3 to divide 729. Or we simply say, how many times will 3 go into 729? Which simply means how many times this 3 divide this 729. And if you shake it on your own, it will see that 3 goes into 729 6 times. Yes, 6 times. So now write something like this. 3, carry this one down. 3 3 raised to power n power 1 is equals to the same 3 raised to power. How many times do I say? 6 times to power 6. Yes, this 3 raised to power 6 is the same thing with this number. It's equal to this number. 3 will go into 7 to 9, 6 times. Having done that, now it's easy for us to cancel out to divide. See, 3 divide itself 1, divide itself 1. So what remains? Nothing remains except n minus 1. N minus 1 is equals to what is here? 6. And if you decide to collect like 10, we'll collect 1 and 6 so that n will stay alone, n will stand alone. And if you want to do it, you do it like this. You say n, now this n is equals to 6. Carry this minus 1, cross this equality sign, come and meet 6 here, it becomes plus 1. So we now have something like this. N is equals to 6 plus 1 plus 1, which give us what? 6 plus 1 is what? Simply 7. So we have our n is equals to what? N is equals to 6 plus 1, 7. You know? So our n is equals to 7. What does that mean? The number of times in this GP is 7. This GP contains 7 numbers. And this last number is the 17th one. This last value is the value of the 7th number. That is what it means. Yeah. So with this now, we can be able to find the sum of these GPS. Now we know how many numbers we are adding. We are adding 7 numbers, 7 times. Let's solve it here. Okay? Now solve it this side. And we're going to use another formula, which is the formula for sum of a GP. It is different from this one. And the formula is Sn. Anything that goes with sum goes with Sn. Yes. Sn is equals to open bracket. Is equals to A for a open bracket. Open bracket. R raised to power n minus 1, close the bracket, all over R minus 1 again. Yes. You know why we use this formula? We use this formula because our R is greater than 1, so it will be easy for us to subtract 1 from it. If not, we use the other formula. Yes, this formula is what we use when R is greater than 1. So we go. Carry down Sn. Sn which are equals to A. What is our A? Our A is 2. It's 2. So we write 2. Open this bracket. R. What is our R? Our R is 3. Is 3. Write 3 inside. N. What is our N? Our N is 7. We obtain N as equals to 7. Yes. Put the minus. Put the 1 that is already in the formula. We close the bracket. All over. R. Say our R is 3. So we write 3 here. Minus this 1. Yes. Okay? We continue. What do we do again? We evaluate. So write down Sn. Sn. Put the equals to. Okay? Put the 2 first. Put the 2. Now open this bracket again. Open this bracket again. Let's put it down here. Okay. Open this bracket again. Now we evaluate. We start with this. We say 3 raised to power 7. You know what it means? It means 3 times 3 times 3 until 7 times. 3 raised to power 7. 3 times 3 times 3 times 3 until 7 times. And if you do that, it will give us 2187. Put this minus 1 that is in the formula. Close the bracket. Okay? All over. We come to this one. Say 3 minus 1 gives us 1, 2. So simple, write 2 here. We continue. We are approaching the end now. We are approaching the end. So we say, okay. Now let's just cancel out these 2's. Yes, 2 is here, 2 is here. You can cancel. 2 cancel is 1. Cancel this one. So what do we have now? We only have 2187 minus 1. What do we do now? We simply subtract it. So let's first of all write our Sn. Write our Sn. This is our Sn. Put equals to. Now we are approaching the end. We simply say 2187 minus 1. We have cancelled out these 2. So you have only 2187 minus 1. Just to subtract 1 from 2187. And if we do that, it will give us what? 2186. Write it down. 2186. Yeah. That's the answer. That's the answer to this problem. Which means that if you add up all these terms, all these numbers in this GP from the first one to the last one, and also write out this one that are not given, if you write them out and add everything together, it will give us, we will obtain 2186. Yes,
I believe you agree with me
that this is a very interesting one. Interesting problem. Math is fun.